Hey, chemistry fans, welcome back. We got another gas lab going today. Me and my trusty assistant have things set up here for you. What I have, I'll show you this. And what we're going to do today is you should have at this point downloaded the Absolute Zero lab. It says Guy Lussac and Absolute Zero. And on top is the data table. There's not much to this lab other than the fact that we are going to test different substances, basically mostly water at different temperatures. I'm going to get the boiling one up here right away. Okay. And what you have in here is you have a gas inside this copper ball. So you're simulating holding the volume constant. And then you have a pressure gauge up here. Okay. And in the long run, what we're going to do when we talk about the analysis later in a different video is you want graph. We're going to be doing 3 different types of graphs on here. One, just plotting your data, and you can do it on graph paper on a computer. And actually, really what we're doing is 3 estimates of absolute zero. Kind of one graph here, one if you have a graphing calculator, some of you don't, but one from a graphing calculator. If you don't, we can't do that. You just have to put that in your write-up, but that's all part of the thing. But as you can see here, you can estimate absolute zero, which is a theoretical temperature. It hasn't been actually achieved by taking some data points and plotting that best fit line and seeing where it crosses the x-axis on temperature. So anyhow, let's get started. The first thing I'm going to give you is just data. Here's my boiling water, and we'll see exactly where it's boiling at with different areas and different stuff. It doesn't necessarily boil it right at 100. 100's about an average. Okay. And this is the exciting part of the lab. This is where the thrills come in as you sit and watch me stare at a thermometer till the temperature equilibrates. Okay. And it appears that we are happy boiling at 98 degrees Celsius. That's 98 degrees Celsius. Now I'm going to put this absolute zero device in here. I'm going to hold it. I'm going to watch the pressure gauge, and this is going to come out in kilopascals, just so you know. And the gauge looks like it's slowing down, slowing down, slowing down. We are 130 kilopascals. Okay. So boiling water was at 98 degrees and 130 kilopascals. Okay. And I'm going to move this water and this hot plate out of the way. Okay. And I'm going to bring in another, I might as well, I'll just do this right here. Okay. This bucket is just our normal room temperature water, which today is at 19 degrees. So room temperature water is at 19 degrees. Set my different thermometers around. And again, I'm just going to put this device in here and let it sink. And the gauge is dropping because the temperature is dropping. And when that settles in, oh, the excitement we're going to have. We appear to be at 105 kilopascals, 105 kilopascals. So that was regular water, 19 degrees, room temperature, okay. And it's at 105 kilopascals. All right, the next bucket I'm bringing over, here's my ice water. Okay, ice water. The ice water is sitting at 4 degrees Celsius. Okay. In goes our device. Temperature's going down, so we hope the pressure's going down. No wagering. No wagering on how many kilopascals this might be. Okay. Ice water at 4 degrees Celsius seems to be 98. 98 kilopascals. Let me move this out of the way. Let me slide another hot plate and beaker over here so you can see it. This is just warm water or hot water. I don't know. This is less than boiling and more than freezing and more than room temperature. So we'll put this under the hot water extravaganza. And hot water is, our hot water is 62 degrees. 62 degrees Celsius. Hot water. Pop in the device carefully so we don't get hot water on the hot plate. And that is 115 kilopascals for the hot water. We have one more liquid that we're going to use for temperature, and that's some methanol, some cold methanol that I have in the freezer because it should go below 0. I'll be right back. Okay, here's our cold beaker of methanol. It's an alcohol, so it has a freezing point well below 0, so we can keep it in the freezer and use it for exciting experiments like this. I'm gonna just check the temperature here. We are dropping well below 0. We are at -11. -11 degrees Celsius. We will see where our pressure goes. And that looks like 93 kilopascals, 93 kilopascals. Okay. So there's our data. Now, we'll do a little video talking about the math and stuff that goes in with the analysis. You are going to graph this. So, and you can see it says absolute zero. You're estimating in 3 ways: from a graph, from algebra, and if you have a graphing calculator, from a graphing calculator. If you don't, we just have to explain that. But you can start doing the graph, which is whether you have some graph paper at home or just do it on some computer graphing simulation. You just plug in the data, okay? And then you're going to want to do a best fit line to estimate where it crosses the x-axis. Temperature is your x-axis. I would suggest with our temperatures a range from about -300 to, you know, about 100. And then the y-axis again was our pressure in kilopascals. So starting at 0 at the bottom and going up to whatever our highest one was, a little higher. I think, you know, we were 130, 140, whatever it was. And then you can just put in the points and do a best fit line to see where, if you do it by hand, just put a ruler in there and see where it crosses the X. If you do it on the computer, have the computer simulate it, but that should at least give you a value. And we hope it's somewhere around -273 degrees Celsius, which the regular one is. Anyhow, that's it for Absolute Zero Lab Day. So from my lab assistant and I, have another great day of education, and we'll talk to you soon.